All right. Well, thank you everyone for coming. My name is Tim Ryan. I'm employed here at City College as the technical operations manager. I used to be the network manager. I have a few other hats that I wear. And I'm going to give a presentation about essentially about the latest standard of Wi-Fi, 802.11ac, but also what you're going to see is a lot of the entire Wi-Fi system that we have here at City College is made by a company called Meraki, which was purchased by Cisco sometime last year. So it started as a startup here in San Francisco, and then Cisco bought them for $1 billion sometime, I think about a year ago or so. And Tad Romer is the systems engineer. He's unable to make it. He works out of Seattle, so he wasn't able to come, but he's contributed to the information here that I'm going to be presenting. So this is a quick overview. I'm going to do a few slides, and then we're going to go to the hands-on aspect of this. And basically, with this new standard, it's really interesting. So the standards are developed by IEEE. They take a long time to develop. So they worked on the 802.11n standard for 6 years, something like that. And so now they're onto the AC standard. And there's products that are available now, what they call Wave 1 products are available now. So the example is the AP that I held up over there. So that's an example of a Wave 1 product, which we're going to be connecting to. Wave 2 products will be coming out later this year into early next year. And then there's also something that I'll use the term later, it's something called the complete amendment, which is an interesting term that I hadn't heard before. That's like the final version of the standard. So the vendors, of course, are in a rush to sell any equipment that's got a new buzzword associated with it. So the vendors, as soon as there's anything to go on, they're going to build a product and try to sell it. Whether it's the final standard or not, they're just going to take their chances, and they don't want to lose revenue or lose market share or anything like that. But anyway, these are the engineering advancements. So these are the things that you could implement into any Wi-Fi curriculum. And we're going to talk through these, and some are going to be easier to explain than others to your students. But you'll see when I talk about the RF spectrum, that's kind of the easiest one, and there's various ways that we have to discuss that. There's other things called MIMO. There's something called beamforming. It uses an improved modulation technique, and then hence increased data rates. So again, these are the big differences from 802.11n to now the new standard 802.11ac. So this is, again, the company Cisco-Meraki. They use a cloud-based controller concept. So we're going to log into the cloud-based controller. You have to purchase the equipment and the license. We have 198 of these APs at City College right now. The one that I have here is it's their model MR34 and supports not only the AC standard, but they always have to back rev and include some of the previous standards because, as we'll see in a minute, the client devices are not always able to catch up. And you have to support whatever client devices are out there. You don't want to force people to go. And so at this point, why don't you go to the site, go to Meraki.com. There's a login. There's written here as well, and pick uppercase letters. I'm sorry, what?
This exists after today.
I'll probably have to take down that login after today, but yeah, it's good for now. So I'm going to switch now to the screen. So this is probably what you're seeing as you log in. You may see something like this as a map. And yes, sorry, this is Tim live. Presenting at City College. How can I help you? Hi, Andrew. I'm in my presentation right now. Is it urgent? All right. Thanks. Okay. So the first thing we have here is a map. So actually, this looks very similar to Google Map. And so Meraki initially was funded by Google, in part by Google. So what I'm going to do is just spend a little bit of time going through it. So if you see over here, is everyone logged in at this point? You see something here? So one of the interesting things, I guess, if you click on down here under access points, so you have just read-only privileges. And this, for example, is going to show you all the access points that we have. And you can see up there at the top 198. So we put them in alphabetical order, essentially based on either building name or campus. So if you'll scroll down a little bit, you'll see under CHI, you'll see that's abbreviation for Chinatown. So we put in quite a few of them here, and then I've done a few temporary for this particular event. And so the one that I have right there is it's what we call CHI temp 11-1102. It's hence the room number that we're in, 1102. There's a few others that we set up in here, roughly one for each of the different rooms. CHIX is the Chinatown Annex. That was the auditorium we were in earlier today. And then you go through Cloud Hall, Downtown Hall, etc. And so I'm going to just focus in again on this screen. So you can see the status, the system name, and usage and clients. So one thing that we find is really useful, we want to sort on number of clients. And part of doing that, although you can look up here, so what we're looking at is things for the last day. So if we just click on clients, it's going to sort them in order of the number of clients for this past day. And again, provide the connectivity, etc. So if I again go by, and then we click it again, and you'll see a number of them we haven't quite put out recently. But this is pretty common. We'll see a lot of really low usage. Obviously, it's Christmas break at the moment. But as much as you want to know where your heavily used access points are, you want to know where the lightly used ones are too. You know, you may shift those to a place where they're going to get more use. So in order to make our statistics a little more interesting, up here under access points, instead of last day, you can click for the last month. And now we'll see statistics for essentially the past month, starting from December 6th on up to today. So now look at the number of clients have increased dramatically. Obviously, it's not real time, but those are how many have connected over the past month. And so again, what I want to do is just drill down a little bit. So if we go into the temp 1102 and just click on that. So now you'll see that we have only about 4 clients currently connected. And does everyone see that? So you just click on the detail for that particular access point, CHI-temp-1102. And so again, this is a cloud-based controller. It's hosted in their data center. It's replicated various places around the state, around the country. And all we have on our campus are the access points. And so once you set up an internet connection, it downloads the firmware or the configuration that it needs and connects to their controller. And so now all of the system administration that we do is done through this web interface. And we can go anywhere and do this.
So this is in place of a thin AP design?
There is a network controller, so correct, it's still a thin AP. It doesn't have the full operating system on it. So it's a thin AP with a controller. And the previous generation of technology, the controller would be in your data center, and it would be your responsibility to keep it upgraded and add new features and all of that. So, and then you have your own reliability issues to deal with. So now and you had to have 2 controllers because you couldn't just have one. So we didn't have much success with the previous generation equipment. There were a lot of bugs and problems, etc. So now the controllers are in their data center. They have multiple redundant controllers. And we simply have licenses to allow a certain number of APs to work. Yes.
Did you say there, so this is like a service you're purchasing now?
Well, you purchase both the equipment, the hardware, and a license. And so just to give you an idea of the cost. So again,
you're just purchasing APs or also the controller?
You purchase APs and you purchase a license.
Okay, and then you just use their controller.
And then use their controller. So roughly, say $1,000 for the total for 5 years. So $500 for the equipment and $500 for a 5-year license.
So do you have to pay anything for the use of their controller then?
No, that's your license.
Okay, that's your license.
That's what you're paying.
Is this the same controller mentioned in the first one?
I don't know which new curriculum is going to cover. Yeah, this is the controller. So again, it's a hosted controller. So it's essentially a basic cloud base.
On this step, are you able to get a sense of examples of throughput associated with each of the APs?
Yes. So that's really interesting. So I'm going to spend a little bit of time on that. That's kind of a good segue. you know, we've all had gigabit connections in our desktop computers for a number of years, and we don't use anywhere near that amount of bandwidth. And so now we have, you know, Wi-Fi products that are promoting themselves as essentially a gigabit alternative to a wired connection. But again, we've never used anywhere near a gigabit. But that's okay. We want new technology. We want to buy it. So it brings up really interesting concepts, though, and some really interesting things that we can measure. So I'm going to show this, for example. So right now, these 4 clients, and again, we're not doing very much, but this is an accurate measurement of Ethernet traffic. So these 4 clients, it's aggregated. They're only doing less than a megabit, basically. I just have a few things running here. This is another interesting thing that you can incorporate into your online learning environment. So the latency, obviously, getting out to the internet, is something that you want to have as minimal as possible. And so this site that I pinged 4.2.2.4, it's level 3, hosts that, and I'm assuming it's at all level 3 offices around, or data centers around the country. If I were to do a trace route to that, I find that it's in Sunnyvale. But 4 milliseconds, or 3 milliseconds out to the internet, I mean, it's not going to really get any lower than that. That's fantastic in most environments. That's your goal as a network designer, network manager, is you want to have as low latency as you can out to the internet. So something interesting, though, is what Google does. So Google, you'll notice, is 20 milliseconds. 20 plus milliseconds, and it's interesting when I trace it. I'm on actually a 802.11 AC adapter on this computer, so Google knows I'm on a mobile device. It's a mobile adapter. They're actually routing the traffic out to Seattle. If I do a trace route, I don't hit Google until I get to Seattle. In this case, if I'm on my regular desktop, then Google dumps me off, or they dump me off to Google in Sunnyvale or San Jose or something like that. So I'm not quite sure why that is, but the key thing here is that this controller is not adding any latency, extra latency. So again, the 3 to 4 milliseconds that I get through the Wi-Fi connection is as good as I'm going to get on any wired connection as well. So there's probably a case to be made that latency, low latency is more important than high bandwidth in a lot of, from a user experience perspective. So with that in mind, how much bandwidth do you use, or do you really need? So if I were to go back here, I can click just the next line down, is called clients. And this is just going to be a summary of all the clients that are currently on the network. And again, I'm just looking at, it says here last week, but I'm going to change it to last day. And this shows you, see the status of green. I'm assuming you've seen roughly the same screen that I'm seeing here. If I were to scroll down, the green ones are active. And so we have about 130 active devices right now. Not all of them here necessarily, but that's across City College. And granted, we're closed for school. So a large number of them are here at this event. And what's interesting to note, so all 130 of those devices, here's a graph of what we've used. We've used maybe a peak of 12 megabits per second for all the devices. And even normally, even like in our peak times, we'll have over 1,000 devices. And I go up to this graph, and 1,000 devices will use 60 or 70 megabits of traffic. So that every single device is under 100 meg. And now, but these products are capable of doing a gigabit to each device. So, there's a lesson there, and I'm not sure quite what it is. But I think the important lesson is for students is to get some comprehension and find tools to measure the bandwidth. And it's amazingly, from my perspective, it still seems amazingly low from what you might guess it would be, or what you might anticipate it would be, or if you read marketing literature, what it might be. But it's, even though people might be doing downloads and web surfing and email, but a lot of people are idle during that time. So again, it's a relatively small amount of bandwidth that we actually use, or throughput, I should say, that we actually use. Yes?
You said it's very difficult to do a gigabyte to every device.
Well, That's so it's a gigabit connection. So physically, from the physical standpoint, from the back of the device, it's a gigabit connection. We have a gigabit Ethernet switching environment. We have a fiber network across San Francisco, and our internet peering point is a gigabit connection.
I mean, from wireless device.
Well, that's from wireless. So I'll show some examples where it's theoretically possible to do that. But my point, I guess, is that from a practical standpoint, it's not anything that even come close to utilizing. But it's there, it's the latest, it's cool. It's not, so even the gigabit connection they put in the back of the computer, that's what, an extra 50 cents? But you know, you never use it, but why not? Why save a quarter and get a cheaper one? Well, who wants 100 meg when you can have a gig?
Now, the experience of an individual client might have depends upon the client device that's being utilized. I mean,
correct.
I mean, so we don't know whether those A, B, N, G devices that are out there. But we have no way of finding that out on those clients. What device are they actually? Oh, what
speed? Yeah, I'm going to show you that in a minute. Yeah, we can find out from this tool what they're doing. So another question? Do you have a question? Yeah. John?
Just one question. When you're talking about clients, you're no longer talking about like, proprietary clients. You're talking about the operating system client now.
When I'm mentioning clients, these are the devices, the portable mobile devices. Yeah, and like I said, I put a special adapter on this one, so this is essentially a Wi-Fi device right now. But that's the good thing, you know, labs like this, they never really move. But, you know, we did spend a lot of time getting the wiring into the floor. You know, it may have been a cost savings measure if we could just done wireless everywhere, even though it's fixed devices, put in a Wi-Fi adapter. So there might be some financial advantage there and new design. So this building we designed it, say, 3 years ago, all the infrastructure. It, you know, just wasn't quite comfortable saying, yeah, forget about all those copper wires. Let's do the whole building with Wi-Fi. I mean, we just weren't it's not quite there. And I don't know, you know, at what point we'd get to that. Cabling it's rather labor intensive to put in. But then again, you never have to upgrade it or change it for decades. Whereas Wi-Fi, it's constant maintenance and upgrades. So there's an interesting column here. So again, we're just looking at the last day, all these devices. So there's an interesting column over here called capabilities. And so we can sort on that capabilities. I'm going to click on it. And I can see that just at the top of this list in the order that I'm sorting it in, and I can go back and forth. Every device, there's a lot of them that are AC capable. I would say a lot, 2, 4, maybe 15 that are AC capable, 2 and 4. And then the rest, here's some that are G. So we have 1, 2, 3, 4, 5, 6. So, you know, 5% of our devices that are here at this conference can only do G. Then N, and now N has both the 2.4 gigahertz, and then there's some N that can do both 2.4 and 5 gigahertz. So it looks like the majority of our devices are you know, definitely N capable, but the majority of those only at the lower frequency range. So we're going to talk a bit about that. That's one of the key distinctions. So 802.11n, you can do both, use the 2.4 gigahertz band and the 5 gigahertz band. And with 11AC, granted it says 2.4 gig, but it's only because it's a backward compatibility to 2.4. So the 802.11ac, one of the distinctions is that it only uses the 5 gigahertz band, whereas N uses both bands. And so there's more and more of these devices. Notice almost all the Android devices are AC capable. And if I were to sort here again by description, if I can go down, let's see. If we do here, and I can't say blanket say it's all these Android. Now here's the list of Android devices that are active, and you can see some of them are N, some are AC. But we're seeing obviously more and more over the past year. It's just been a big increase in Android operating system mobile devices, and now it looks like they're actually leading in terms of the capabilities, in that a number of our, you know, good percentage of the devices that are AC capable are Android. So one thing I'd like to point out with respect to the, you know, statistics. So if you go over here on the left again, summary report. So this gives us, so again, in order to gather a lot of data, you can see up here we have this for the last month. So that's as far back as we go. I guess it could do a custom range. But going back over the past month, so you can see in the week of December 10th, we were actually pushing up to maybe 120 megabits per second. But again, that was with at least 1,000 active devices at one time. And what's interesting to see the top access points by use, the SSIDs, and the models. But what's really interesting down here, the applications that they're using and the operating systems and the device manufacturers. So we can see that Android is catching up. About 19% of the clients are Android. The iPhone is still by far, well, not by far, but the most common single device, 29%. Other Mac devices are in various levels of percentage, but when you get into the Windows, it drops off dramatically. Windows 7, 9.6, Windows 8, 6%. So you can also see by device manufacturer. So it's not clear exactly which type of device you have. Obviously with Apple though, so 62% of the clients are have the device manufactured by Apple. So between the iPhone, Mac OS, and iPad, and Android then kind of gaining pretty quickly. So we don't spend a lot of time looking at these. It's just kind of interesting information to see how things are changing. We do look a little bit at the applications. So this is usually pretty uniform. So miscellaneous web, Google, YouTube. It looks like YouTube has dropped a bit, and Facebook is now down to 2.7% of our usage over the past month was Facebook. Yeah, it captures it by URL, and again, this is some things they're gathering within their controllers. So all the traffic is going through the controllers, and so they're able to tell, put it in some categories. So iTunes is over twice as popular as Facebook, for example. Yes?
Are you using this in the classroom?
We have Wi-Fi device, not in every classroom, but this is just the Wi-Fi coverage throughout the college.
Do you teach your class in Wi-Fi that you use in this college?
No. It'd be, it's interesting, I think, like you said, that's the point for this presentation, to bring a lot of these technologies into the environment, but to put a class just around this. We have some student workers who are getting great hands-on experience helping us out, so they're learning a lot about putting out these different systems. This is an interesting one too, the top clients by usage. So, we see people here with, some of them are identified by the name, but others are not. So, we have a registration. Normally, people have to log in with their student ID and a password. We've just set up guest service here so that anybody you don't have to go through a registration process. But in reality is, if we get some complaint, or if we want to trace back to a certain source or a person logging in with the device, we'd have that capability through this. So again, I'm going to just look then at the last day, and this gives us maybe a little more accurate information with respect to this conference. And we can still see, it doesn't look like these statistics look roughly the same. Even though we have a much smaller sampling here. We have a total of, several hundred clients, but iPhone is again 29%, Android roughly 20%, Windows 7, and a few Windows 8. So interesting, yes?
I noticed it looks like the guest network, but is this segmented off by VLANs or different networks for your administration?
Well, no, that's interesting. We just do, we set up guest, and now I've set up a separate one with AC. And down here is where I, set up the different SSIDs. But typically, though, there is very little what I call administrative function for the Wi-Fi. So it's pretty much purely academic purposes. So if anybody wants to get into any administrative system, they have to use a VPN. Log in here and then do a VPN. So these are the shades that decide to go up and down once in a while. One of these, next button over. The next one over. Is it shades or is that light? Try the button before then. There you go, just let it go down. A lot of building management systems in here that I had got involved in setting up, and this one in particular is tricky. I don't know why. There is some controller to it, but anyway. The interesting thing with building management systems, they're using a lot of BACnet now instead of Ethernet. So these BACnet, it doesn't use IP addresses. So it's amazing. You set up a VLAN on either end, and it does BACnet over Ethernet. And of course, it isn't like some master plan. They come to us and say, help us design the BACnet to work in the environment. I get a phone call that says, hey, the BACnet isn't working. So what's BACnet? Never heard of it. Well, it's not working. Okay. Anyway, so we can set up the different SSIDs through here, and we could set up special ones for various reasons, but we usually just have the CCSF wireless where they authenticate in, and occasionally in some public areas we'll put in CCSF guest. So I'm going to just go back to under the monitor mode. So I wanted to just show a little more detail about the access points. And I'm going to go, looks like this one's pretty lightly used, but I want to just show again, this is the one that I'm currently connected to. And so 4 client devices. And if I click here on channel utilization, so this is a really interesting aspect to this. So the channels, right now we're using channel 11, which is one of the traditional 802.11b channels. And also though we've introduced new channels now, the higher numbers channels like 157 are in the 5 gigahertz range as opposed to the 2.4 gigahertz range. And this is interesting because what we're trying to do, from sitting here with this controller, we've got great tools, but we're trying to figure out what is the real user experience. Do we need more APs? Do we need to place them differently? You know, what is the user experience out there? Are they dropping, you know, what's the capacity of an AP? And so there's no real easy answer to that. The capacity is greater with the newer systems, but it still doesn't tell you, you know, what if you're in a crowded lecture hall with 200 people all connecting to it? You know, what's their real user experience? And so this is kind of the closest tool that we have right now to tell us what that user experience is. So we know that the channels are not very heavily utilized. Yes.
Did you proceed this with a site survey? I mean, did you try the placement and I mean, it seems like this is, you're talking about this, but like it was installed, but you really didn't do any.
Well, so it was installed. So with the size, we have 2 million square feet within our college environment. So there's no way we could even initially cover all that. So the initially is we get 10, we get 50, we get 100 systems. So let's start to put them out where they're going to be used. And then you got to place them places where you need a wired connection. You can't just pick randomly, oh, this looks good on the top of this brick wall. You have no wired connection there. You need to connect it to a wireless port. And then you want to hide them too. So we put them initially in our telephone closets so they're not stolen. So now we're just now going around to find where do we ideally want to put them. So we put them in the library. You know, a lot of open space there, the cafeteria, those places are pretty straightforward to put them into. So now we're just trying to fill in the gaps. We have about, like I said, 198. I estimate we need at least 400. So we'll need at least 200 more to really do blanket coverage. And then you get these clusters of people. You don't know quite where they're going to be clustered. And, you know, they've been moving around. We try to put them, we had some higher capacity radios that we now have this moving shell game. Let's try to get the higher capacity radio where we're going to get the most students. But now the students have moved over there, you know. Go ahead.
Is there a limit on the coexistence for AC? How many access points can service the same?
Yes. So you do need to do some kind of planning around that, and they can start to interfere with each other. You kind of want them to be spread out a little bit. You can do some channel management, so you can limit them to only certain channels. Or as it is, they have some automated method to find other systems and kind of utilize other channels. So sometimes you'll get some interference with them. But we're just now trying to get to that process where you do a real detailed survey. But again, you don't really know where you're going to get greater capacity. So here's now down in 1104. It looks like it's getting used quite a bit more. So here's 20 clients, and this is just down the hall. So there's 20 clients there. They've all gone in as CCSF guests. And when I look at the channel utilization there, so it says it's high, likely a problem. But on channel 36, which is a greater capacity channel, it's still not into the 5 gigahertz range. But there's plenty of space there. But we have to somehow have devices connected to that channel as opposed to the other one. So there's still a lot of things that we're not able to fully predict. Let's see. So there's other devices here. I was going to just show, let's see, how much time we have till 2:20?
Yeah, 2:20.
2:20, okay. So there's other ways that we can tell what the channel utilization is, what the capacities are. And I'm going to just go into a couple of these. So here's a tool called Traffic Analytics. So this is on all of them. So again, this is just looking at the total traffic with the client counts. So if I go over the last month, this will kind of put it into perspective a little bit. So again, you can see obviously there's a direct correlation, but look how many clients, the size number of clients we had, and the amount of utilization. We never really exceeded, at least according to this chart, never even exceeded 100 meg total in aggregate. I can also click on the, when I went to the, and sorry I'm bouncing back, but I'm going to go to back to the device that we have here. And if I click on the clients, I can actually see the capabilities of that particular client. So I'm clicking on the one that I'm on now, so I can see exactly which device I'm on, and I can see the capabilities of this device. So I can see the channel width is 80 megahertz. So I'm going to talk about that in a bit. The maximum bit rate here is telling me it's 2.6 gig with 8 spatial streams. So spatial streams are another one of those new features that have been improved within 11n. I'm going to go back to another device here, and I'll take, this is my laptop that I have here. So this is just purely an N device. So again, it's an AC adapter, and my laptop has an N adapter. So you can see the channel width available to N is only 40 megahertz, maximum bit rate 300 meg, and spatial streams only 2 spatial streams with a N device versus an AC device. So any more questions on this? I'm going to jump back to some PowerPoint slides. Yes?
Can they or do they actually capture packets? Or can they capture packets traveling?
So our wireless provider, you mean?
And ultimately you.
Or the people who are on these on the Wi-Fi.
About, for example, can you use it to capture packets and spy on what people are transmitting over the wireless network?
Probably not this, but I mean I could just run that on my laptop, but then it's not a central point.
I'm just curious about that, because that's a huge issue that's going to happen if these wireless providers. You know, we could try. Haven't worked with that much. So it could capture all access points. Here's some filter expressions, etc. Could start a capture. Looks like there was a problem running the PCAP. Too many access points were selected. I have all the access points here, so I have to work on that. But I guess what you're saying is we're trusting the Wi-Fi vendor now with all of our traffic, correct? So I think we face this too, because anybody could be sitting out there running Wireshark or something on their laptop, sitting in a library, and are they capturing all their fellow students' information? So we typically, here we're not in a secured network, but typically we do use a shared key, but you have to tell everybody what the key is. So it's shared. It's essentially a public key. Otherwise, people couldn't get on. But it's my understanding that the key, there's some type of a constant change that's going on with the key, so that you're not essentially able to be in the exact same data path, if you will, of everybody else that's using it. And also, I think once you log on to anything, unless you're just general web surfing, once you log on to something, you typically go to an HTTPS connection. So when you log on to Gmail or log on to check your email or your banking or anything like that, you're going into a secure connection. And I don't think that secure connection can be viewed. Yeah, that's encrypted end to end.
Do you know whether this has the capability of setting disassociation frames or getting rid of rogues or?
Well, yeah, so the rogue thing is actually interesting. There's something called air marshal,
And this is one of the capabilities that we said, all right, we want to know where we want to find those rogue devices. And let me just make sure it's connected. And there's so many. It's just taking a bit of time here. I have to get out of the packet capture. So notice there we're in beta still on this particular one and some other features. So they're constantly adding features. In fact, down at the very bottom, you'd see something, I wish this page would. And whatever page you're on, you can essentially make a wish. And that's essentially your way of asking for new features. And we've been making wishes. We've had a few wishes granted. Not all. But you know, it's a great feature for feedback. And so there's only now seeing, like it says, 4 rogue SSIDs, and they say they're seeing these that are on our LAN. So these we would go take a look at. Quite often we see other SSIDs, you know, there's, I'm going to just do a large number of them. But again, going around the city, you know, where these things are picking up all of these at some, you know, signal strength, that there's so many that it's meaningless to us. You know, if there's a rogue AP across the street, we don't care. All we know is, unfortunately, it's being picked up and it's being looked at, viewed as a rogue AP. And so we do take a look at these things once in a while. And so something like this, we track it down. This is a DeskJet printer, so maybe that has a Wi-Fi connection to it, as well as being on the LAN. One other thing that's really important with respect to the quality of the experience of the users is how close they are to the access point. And again, we hide them so they'd have no idea where they are. And you can look at the bars or so and see, you know, most students will figure that out. You're going to get better connection, but it might not be intuitive or obvious to people. But here's where this is telling us the actual signal input that we have. So again, we're pretty close to this AP. It's right here. So the closest you'll get is maybe about 70 dB signal strength if you're really right next to it. Here I'm just a little bit of ways away, so it's 50. If I go to one of the other ones where we had a lot of people and just take a look and see the signal strength, I can actually sort by signal strength. So I can clearly see that some people you know, are fairly close to it, and others are just not going to have as good of an experience as you go down here. And so there's not an easy solution to that other than to add more exit points. And so what we're trying to determine, though, is somewhere there is a minimum level of signal strength that you want to have available everywhere. So when we go into a lot of our classrooms, here it's not so bad, but we have buildings built in the 30s with, you know, thick walls with rebar in them. And the signal doesn't go very far from classroom. It doesn't even go from classroom to classroom at all. And so it's going to really come into play. We're going to have to set a minimum signal strength. We think it's right around 20, maybe 25 dB for minimum signal strength to make an acceptable signal in various places. Then you still have the capacity issue. You still have a lot of variation in the clients. You still have a lot of other variables to deal with that. So, good questions. I'm going to now switch over to the PowerPoints. I have about 10 minutes to go. And these are just some of the things that I captured when I went through the various things here. So you can see, you know, again, when I click on certain access points, you can end up getting a lot of information about which channels are in use and the capabilities, etc. I noticed too they all have a MAC address and a serial number. So you register by the serial number. So that's how we keep track of these. So again, just to kind of go through the summary. So 802.11ac uses 5 gigahertz frequency only. And again, we get 80 megahertz channel bandwidth, up to 8 spatial streams, but I don't think this is capable of that yet. I think that's something that it's getting to within the newer generation products. It went from 64K to 256 modulation, and then I have some information about beamforming. So this, I think, though, is probably one of the things that you'd really try to focus in on for your students. You know, put it in perspective of all the RF spectrum that's out there. And this is the U.S. frequency spectrum chart. This is as of 2011. So it is changing a little bit, but you can zoom in on this. There's a lot of really good information here that helps put it in the right perspective for your students. So for example, analog television. A lot of these up here, this is great frequency. It has a lot, it travels well through walls, etc. And of course, 50 years ago, they said, hey, that's perfect for my television. But now we don't have analog television anymore, and so now that spectrum is what they're starting to carve up. As you get down into here, there's a lot more detail. And I think our 2.4 gigahertz spectrum is right around here, and 5 gigahertz is right around here. So you can have the students zoom in and take a look. Here's the 5 gigahertz spectrum. And, you know, it's busy. In fact, some of the channels we were using are right around in here, kind of the amateur bands that are sort of spread throughout this 5 gigahertz range. And it's hard to stay current. So this is from about a year ago. The FCC says specifically they can open up almost 200 megahertz of new spectrum all within the 5 gigahertz band. It has less interference, but shorter ranges. So that's another trade-off. You go to these higher frequencies, you get greater bandwidth, but now typically your distance isn't, the range is poor. And so there's some trade-offs there, and that's why they've come up with some of these other technologies in order to accommodate that. So here's the channel bandwidth, again, kind of the summary. We have the Wave 1 products, which is what we're using now, Wave 2, and then complete amendment. So if you come a year from now, hopefully we can do another presentation. We show you the Wave 2 802.11ac. And then the year after that, I'll have a presentation about the complete amendment. I'm going to get some mileage out of this topic here. But in any case, you know, they say in theory you're going to get up to 8. We already had 8 spatial streams, but you can see the data rate potentially increasing. But the tools to measure it are not quite there. And again, the actual need for it. Yes?
Are we going to get to a point with the channels that we're going to have wireless switches? I mean, once you start going 8, maybe 16 on the next one, you could have one box out there. Everyone has their own wireless channel.
Yeah, it could be. I mean, you just right now we're still in the model where you get on a wired network as soon as you can. But yeah, we can do wireless meshes. So the Wi-Fi devices can connect to others. So you don't necessarily need the wired connection, but you need the power. So we're never going to go away from that. So now not only do we get a gigabit wired connection right there, we get power over Ethernet to power the device. So if you just put these up in various places without the wired Ethernet, you're going to need a power outlet next to them.
Access point to the cars now, so I mean,
yeah.
Space-wise, you can fit it in one place.
Right. So this one's interesting. So this 802.11ac introduces what they call the multi-user MIMO. So the MIMO was always there. It allows multiple antennas per radio. So that device actually has 3 antennas in it. And so 2 of the radios are typically used for communicating out to the mobile devices. And a 3rd radio, a lot of times the radios talk to other radios. And so it's kind of offloaded some of that into that 3rd radio. But 802.11n was a single MIMO, and now 802.11ac allows multiple users to talk over multiple streams at a time. So again, this isn't anything people notice, but this is something where you're now getting greater theoretical throughput. Whether you could still have a bad connection if your signal strength isn't very good, or if your device has some type of problem.
Do you know of client devices that actually will support many streams?
Well, this client device supports the AC, so if it has the AC adapter, it's my understanding that it'll support those multiple streams. Really? If you have the AC adapter, or AC capable.
Which one is that?
This is one from a company called TrendNet. But like, see, I think any Android device now, it looks like it's going to have AC. And a lot of Mac devices too. Okay. So here's the spatial streams. So this is pretty interesting. This is kind of how they come up with some of these theoretical numbers. So I'm going to get to one other function. Here's the amplitude, the QAM modulation technique. So you could go into some detail about the difference between the 64 QAM and 256 QAM in terms of description of the benefits there. And then beamforming is something where it uses multiple antennas. It focuses the signal on the receiver. So this is the way they overcome that limitation of the 5 gigahertz range, is they come up with more creative technologies in order to focus that signal. And 802.11n could do it, but with 11ac, the point is that they're standardizing on that beamforming. This is just another quick way to show, kind of describe that. So today's Wi-Fi is kind of this, symmetric distribution of radio frequency, whereas the beamforming is now more from the device to the client. Yes.
On the beamforming, they're using like a phased array, but does it make a difference how you're?
Yeah, I think it definitely makes a difference. Notice even in how you hold the device, maybe not so much with an iPhone, but with the laptop. A lot of times the antenna is around within the frame of the screen of the laptop. It can make a difference how its orientation.
Because the new ones are designed to sit up like that, or the new ones that are.
Yeah, and typically, and also much better, you want to typically would mount it up on a wall. And again, the higher it gives a little bit better coverage. One last thing, and then I'll do a quick live demo of this. This is our usual speedtest.net. And these are some of the speeds that I've seen on this. So again, it's gigabit everywhere. So in theory, I should be able to get a gigabit, but I probably won't. And there's, again, the limiting factors are a few different things here. But again, you'll see if I start this. So this is something that your students can work quite a bit with. So a lot of it's going to depend on the latency. And then we're at the limitations of the tools, but you're going to hit a limit somewhere, whether it be within the the bus structure of your device. Definitely newer devices have improved. This is a fairly new computer, so you'll see this throughput speed increase dramatically just getting a new computer. So it's still hitting a limit somewhere, the upload and download speeds. But ideally this would be a gig, 1 gig. We have the capability to do 1 gig, but like I said, there's a limit somewhere. And if you improve one limit, you find the next and the next. That's what engineering is all about. So, so I don't know quite what the limit is at this point, but that's what we have for today. So.